Hi everyone, my name is Rachel Bernstein and my Capstone partner is Olivia George. Our Capstone project is titled Sustainable Conversion of an Office Building to Affordable Housing.
So this project was born out of two critical issues. The city's ongoing affordable housing shortage, which has only been worsened because of COVID-19 and soaring unemployment rates, and the increasing share of vacant or now underutilized office spaces. The demand for affordable housing continues to outpace supply. Even with Mayor de Blasio's ambitious Housing New York plan, which was released in 2014 and updated in 2017, the goal to preserve or construct 300,000 affordable homes by 2026 falls short of demand, so new avenues for development need to be considered. As of the first quarter of 2021, office vacancies reached a 27-year high at 16.3%, and offices are unlikely to return to their pre-pandemic occupancy rate, especially as working from home continues, even if it's just part-time.
To deal with this multifaceted problem, we aim to address it in several ways through a hypothetical case study of a conversion of a vacant office building in Manhattan. Therefore, our plan is taking a vacant office building in Midtown Manhattan and converting it into a mixed-use space consisting of affordable housing, single-room occupancy units, also known as SROs, with options for 1 or 2 people in each unit, 2 and 3 bedroom market rate condos for families, a ground floor grocery store to address the problem of food deserts in Midtown, as well as an employment opportunity for those living within the building, and a daycare center on the ground floor for residents of the building, as well as others in the area. Within the building itself, we plan to implement high-performance building design applications relating to Passive House with a specific focus on improved ventilation in the age of COVID-19. Additionally, this building will be able to meet criteria for the enterprise green communities, well, and discussions on the impacts of photovoltaic panels to this building.
So we wanted to tie the sustainable development goals into our project, and here we highlight the 5 that are most relevant. Number 1, no poverty, since we're addressing housing affordability. Number 2, zero hunger, because this project will include a grocery store in a neighborhood that is currently a food desert. Number 3, good health and well-being. The pandemic has really emphasized the importance of healthy indoor spaces. So this project focuses on things like improved ventilation and building health. Number 7, affordable and clean energy by incorporating rooftop solar panels. And number 11, sustainable cities and communities by ensuring access to safe, affordable housing with basic services and proximity to public transit. Throughout the presentation, we've indicated which of these SDGs aligns with each topic by placing an icon at the bottom of the slide. So one of the first steps in this project was to select a site to build our plant around. We researched and compared commercial buildings that are currently for sale either partially or in full, and then settled on a building in Midtown Manhattan, which is a central business district with a current office vacancy rate of 16.8%, so slightly higher than the average in Manhattan. The building we chose at 35 West 36th Street is 12 stories, and all units in the building are currently for sale. A deli previously occupied one of the ground floor spaces of the building, which aligns with our goal to create a ground floor grocery store without starting from scratch, since it was set up for food service and equipment rather than being something like a clothing store or a salon. And earlier this year, we visited the building and agreed it would work with our plan to convert it into affordable single-room occupancy units.
So by definition, an SRO is a unit with 1 or 2 rooms lacking a complete bathroom and/or kitchen facilities for the exclusive use of the tenant. So for some history, during the middle of the 20th century, SRO housing took over the New York City housing market with thousands of people using this as a means of living in New York. SROs were a very popular housing option for single, poor, working class men and less often women. In most SROs, the room contained a single bed and closet, sometimes a sink, with shared living amenities available within the building. And in the 1920s, landlords began illegally dividing up the larger spaces and renting them out as SROs to poor individuals. And throughout the 30s and 40s, this conversion continued in an effort to house factory workers, then returning soldiers, migrants, and immigrants from Puerto Rico. By mid-century, there were over 200,000 SRO units in New York City, making up over 10% of the city's rental stock. Eventually, progressive era reformers became actively anti-SRO due to class biases, social prejudices, racism, and xenophobia. The breaking point for these individuals was when larger, usually immigrant families replaced single people living in SROs, and the city quickly responded by doing all they could to put SROs out of business. The changes that the city made included banning new SRO units, restricting families to live in SROs, mandating the reconversion of SROs, changing the building and zoning codes to disincentivize SRO occupancy, and for a certain period of time, the city provided tax incentives to encourage conversion of SROs to more expensive apartments. Our goal through this Capstone project is to fill office buildings that have become vacant due to COVID-19 with affordable housing units, such as SROs, to address the housing crisis in New York City that has been worsened by the pandemic. Because there's a change of occupancy in the building, as it was formerly an office space and creative loft space, there needs to be a change in zoning. So the building is currently zoned as an M16 light manufacturing district. One would traditionally go through the ULURP procedure to change zoning on a property, which can take a while, as is demonstrated by the chart. Our proposed zoning change would be to a mixed-use zoning from an M16 to an M12/R10, which guarantees a variety of different uses in the space. And since Midtown is quite dense, R10 made the most sense within this exact building and neighborhood. So this shows the physical building in Midtown that we selected at 35 West 36th Street. The middle image shows our breakdown on what is designated for each floor, and the rendering on the right is the final product of what our hypothetical building would look like. This axonometric drawing expands on the last slide by showing a 3D perspective with each element of the building labeled. So as mentioned previously, the ground floor will consist of a grocery store and a daycare. Floors 2 to 4 will be condo units due to the lack of windows from neighboring buildings, which impacted how many bedrooms could be used. And beginning on floor 5, the neighboring building is unobstructed, allowing us to use 3 of the 4 walls for bedrooms for the SRO floors, with SRO floors going up to the 10th floor. So there are 9 SROs on each floor with 54 units total. And due to the condos being marketed as luxury spaces, we wanted to give precedence to them by giving the penthouse floor and the floor below to add more luxury condo spaces, each consisting of either 2 to 3 bedrooms, a personal washer dryer, full kitchen with a dishwasher, large open living room, large extra closets for storage, and some with an additional office space. So the next few slides show the real-life images that we took personally during our site visit in January compared to the renderings we produced in SketchUp. So this first slide shows the ground floor conversion from what was previously a cafe and boxing gym to a grocery store and daycare. Here we show the interior of the grocery store, how it would look after being converted from a deli. Due to the existing equipment left in the space, this would be an ideal conversion of space. This rendering shows the ground floor daycare center.
And here's an overview of the ground floor layout. So the grocery store is up here with the entrance coming off the sidewalk, and then the lobby of the building with elevators leading to the residential units. And through the lobby is the entrance to the daycare center.
So here we move on to the SRO floor, displaying the built-out shared kitchen. This shows a few bedrooms in the SRO space. They all consist of 1 bed, or in some cases 2 beds, a nightstand, dresser, and closet. On every SRO floor, there will be a common area with sofas for community interaction, a full kitchen with 2 refrigerators, a stove and oven, dishwasher, sink, and a considerable amount of storage for food and dishes, an office nook with a row of desks and computers for those working from home still or in need of studying somewhere outside of their bedroom space, a shared bathroom and shower area, and also each floor will have access to laundry machines.
So here's the full floor plan with individual SROs along the front and the west side of the building. And then the back of the building has double rooms. And then here's the individual toilet rooms and the shared shower with the open kitchen and living area, and then some desks and an office nook over here.
So now we move on to the renderings of the condo spaces. This one shows a blank space on the left with the rendering of a 3-bedroom condo unit on the right. As you can see, there is an elevator lobby, 2 children's bedrooms, and it opens up to a larger living space in the back. These renderings further display the condo units with the full open kitchen and living area, the large master bathroom, the office space for the 2-bedroom units, and the master closet and bedroom.
So each condo floor will have 2 condos, one on the west side and one on the east side of the building. We aligned kitchens and bathrooms to match the building's existing facilities, so it would save on cost. And then in the units where there's no windows along either the east or the west facing wall, we put an office or bonus room to maximize the space. So all of this is obviously going to come with a huge price tag. And in terms of financing the project, there are a variety of options available, including grants, loans, and tax incentives. And the chart here is a sample of what could be used in the project based on its size, the target resident income, and project components such as solar panels. Home is a common grant this project could be eligible for. The New York City Acquisition Fund provides loans for affordable housing projects. LIHTC is a competitive tax incentive administered through HPD. And then by incorporating solar panels, the project could be eligible for solar roof tax abatement. Some financing options require that a project target certain incomes, which is based on the New York City Area Median Income, or AMI. And the median income is defined each year by the US Department of Housing and Urban Development. The 2021 AMI for the New York City region was $102,400 for a 3-person family. So that establishes the 100% AMI baseline. Home program funds are only available for projects that target households with incomes at or below 80% of AMI and primarily below 60% of AMI. And LIHTC's 9% competitive funding is points-based, with more points awarded to projects targeting lower income brackets. So to satisfy all these requirements, about 90% of the affordable units in this project will be at or below 60% of AMI, with the remaining 10% for households at or below 80% of AMI. And because the affordable units in this project will be SROs, the maximum occupancy is 2 people. So this chart just highlights the households that would be eligible. And because the entire building is currently for sale, we were able to get an accurate purchase price. The $83 million full building price tag comes from a commercial offering plan from the end of 2019. And as of February 2021, most units were still available for purchase. So this acquisition cost could potentially be reduced given the declining value of commercial properties over the last year. The construction costs here were loosely estimated based on the number of units, bathrooms, and kitchens, plus 20%. And then more accurate costs were calculated for things like the air filtration system that we'll talk about in a bit, solar panels, and some certification fees.
So Passive House is a German building design standard that concentrates heavily on reducing energy usage through a rigorous and integrated set of principles, focusing on high performance fenestration, thermal bridge-free construction, continuous insulation, airtight construction, and mechanical ventilation with heat recovery. And Interfit is the Passive House standard for retrofits, which has slightly more relaxed requirements. Buildings that meet the Passive House standard use 70 to 90% less heating energy than conventional buildings. They have excellent indoor air quality, superior comfort, and are resilient in the face of extreme weather. Given these benefits, it's no surprise that Passive House construction is gaining momentum in New York City and that local building codes are moving towards Passive House levels of performance. Originally, we had wanted to incorporate several of these principles into this hypothetical design. However, due to lack of information provided by the building owners, we were not able to get specific details about the wall assemblies, and therefore we decided to focus our high performance efforts on ventilation, as that is extremely relevant in the age of the coronavirus pandemic, and which is also very relevant to our project. So an HRV is an energy recovery system consisting of 2 sources at different temperatures, as heat recovery is used to reduce the heating and cooling demands of the building. So we plan to use the Lunos HRV systems in this project. The Luno system has a low noise level, it's lean in that it is the smallest home ventilation system with heat recovery in the world, and it is a ductless ventilation system, so it can provide continuous and balanced heat recovery ventilation without the need for additional ductwork. For condos, we plan to use the Lunos E squared. The Lunos E squared works in pairs to replace indoor air while maintaining a comfortable temperature year-round. So this through-wall variable ventilation system employs a ceramic regenerative heat exchanger to provide continuous ventilation. And the way the Luno system works is actually quite simple. The internal conditioned air is first brought through the fans as exhaust, charging the ceramic core inside the insulated E-square fan unit. And the fan then pauses, reverses direction, meaning the outside air is now being drawn through the charged core and the filter as supply. And they've been tested and operate at 90.6% efficiency with a constant change in air direction. For the SROs, we plan to use the Lunos Ego. The Lunos Ego is an all-in-one room ventilation system with a built-in regenerative heat recovery core. The Ego is ideal for bathrooms and single-room spaces that require continuous heat recovery ventilation. So rather than having two fans like the E squared, the Ego combines the 2-in-1 and into one through-wall ductless unit that covers about 430 square feet, but still functions in the same way as the E squared. So for the Ego, one fan operates the supply while the other is exhaust, charging half of the heat recovery core at a time. And the Ego fans pause and change direction about every 55 seconds, and they operate at about 85% tested heat recovery efficiency. MER filters, or minimum efficiency reporting value filters, are being considered for this project. The MER 13 filter is the most cost-effective option, and as an affordable housing project, financing availability is key. So the Lunos HRV systems have been tested and are compatible with MER 13 filters, and these charts summarize the percentage of particles trapped in a filter by the size of the particles. So as you can see, MER 1 does very little, and MER 13 and higher perform best.
The Enterprise Green Communities Criteria Guidelines were developed as a framework for aligning affordable housing with green building practices. Housing developments that receive funding through HPD are required to adhere to the NYC overlay of the criteria, and certification requires review in the pre-build and post-build phases of development to not only build with these criteria in mind, but also follow through and engage residents post-build. There are 8 categories that address all components of development, such as community engagement in the development process, minimizing water consumption and energy use, material selection and waste management, and health-oriented design. It's a very comprehensive framework that would be very beneficial for this project. The Wellbuilding Standard is a performance-based system focused on building health and well-being. Affordable housing that is Enterprise Green Communities certified will also earn WELL certification. The aspects of the WELL standard are integrated throughout the Green Communities criteria. The WELL standard is broken into 10 categories that address all aspects of building occupant health, as you can see in this graphic. And to ensure continued building health and well-being, the certification requires renewal every 3 years. In light of the pandemic, the International Wellbuilding Institute created the WELL Health Safety Rating, which contains a subset of the Wellbuilding standards, but focuses on facilities operations and management. So it's a stepping stone to full WELL certification that highlights the more urgent pandemic-related issues like sanitization procedures and air quality. But this project would be achieving the full Wellbuilding Standard certification. The final component of our project is rooftop solar panels. Including solar panels would provide a small tax incentive under the solar roof tax abatement, and it could reduce electricity costs for the building common areas by about 16%. Using the New York Solar Map tool, you can see that a portion of the building's rooftop is unshaded with the potential for about 600 square feet of space for solar panels. Adding a green roof was also an alternative option, but since the building has skylights, modifying that would be another added expense. And because this project is to serve as a case study for other similar projects, solar roofs and green roofs are something to consider in order to generate renewable energy or to minimize energy consumption through the insulating effect of a green roof.
While this project is specific to New York City, these social, governmental, and economic problems are not unique to the area. If the concept of SROs is going to be reintroduced to the real estate market, laws need to be put in place to allow this type of project to come to life and to protect the occupants of such spaces. Additionally, city government agencies and departments must be examined to ensure legality behind their work with stringent check-ins. This is deeply a governmental problem rooted in racist histories and flawed corrections programs and policies. A new city agency should be proposed that specifically checks on housing quality on an annual basis in order to make up for lack of enforcement and previously racist policies. Additionally, there need to be greater avenues to access affordable housing. This design is certainly unique, but it can serve as a model for other offices in New York City and elsewhere to address the issue of homelessness and housing affordability.